morning, Jordan.
Good afternoon, Miguel. All right. Okay, so in this figure, how can you figure out the measure of HIF? HIF. HIF is this one right here.
Well, you know they're never equal.
Which one? HIF is alternate interior to what? IHG, this one right here. So if this is 58, this one must be 58. Okay, how can you figure out then HGD, which is this one right here?
You find, because since it's a straight line.
Which one's straight line?
Like, well, if you do 58 minus 180.
Yeah, why though? What are these two angles? Same side interior. And if they're same side interior, they add up to 180. So then it must be, it ends up being 122. Thank you. Okay, you could also say if this one's 58, then you know that this one is 58, and then you can subtract it from 180 because those are supplementary. So either of those ways would work, all right? Either of those are good. You just need to subtract it from 180. Okay, so then how do you figure out the measure of angle D? Corresponding angles would work. Yep, corresponding angles, that one was 58 degrees also. All right, good job. Okay, so we are going to talk about inequalities in one triangle today and the angle-side relationships in triangles. Essentially, what you know about a triangle, these are the long-winded way of saying this, but what you know about a triangle is the angle that's opposite the longest side must be the biggest angle in the triangle and vice versa. So for example, if I have this triangle right down here, and one of the sides is 10, and one of the sides is 18, and one of the sides is 22, let's call this triangle X, Y, and Z. You can put those angles in order of size from either least to greatest or greatest to least, because the angles that's opposite the biggest side is going to be your biggest angle, and the angle opposite your smallest side is going to be your smallest angle. So which one of these would be the smallest angle then? Z would be the smallest angle because 10 is your shortest side and Z is the one that's opposite that side. So this is your smallest angle. All right, which one would be your biggest angle? X would have to be your biggest because it's opposite the biggest side. So here's your largest angle, your biggest angle. And then the middle angle would be Y. So if I were going to put them in order, I would do it in order from least to greatest, would be angle Z, angle X, angle Y. Great job. All right.
Is that how you just do it?
That's what the questions are going to ask you to put either the sides or the angles in order. So this part's pretty simple. You're just figuring out which ones are opposite. The mistakes people make is which ones actually are opposite the angle. So just be careful with that. Okay? And it works both ways. So this theorem just says that in a triangle, the larger angle is opposite the longer side. In this one, it's just backwards. The longer side is opposite the larger angle. So this would be kind of like the what? This theorem would be like the... Yes, this would be like the converse of this theorem. So this first one, 551 and 552 are kind of converses because converse just means you do what? You just flip the order, right? So if A equals B, then B equals C, A. All right. So then in this top one, write the angles in order from smallest to largest. So in this top triangle, write the angles in order from largest to smallest. So we've got angle H, angle G, and angle J. Which one of those would be your smallest angle? Why would it be H? It's across the street from the shortest side, right? And again, is angle H equal to 27.2? No, because 27.2 is not an angle. That's the measure of the side. So that means angle H is the smallest one because it's across from the smallest side. What's the middle angle? Angle J would be the middle angle. And then what's the biggest angle? Angle G. Good. Okay. Down here, write the sides in order from shortest to longest. I only have two angles though, so what do I do first? Add them together and then subtract from 180. So 54 plus 39. 93. So this angle M is 93 degrees. So then if that, wait, sorry. That angle is not, well, all right. Okay. All right. Why is it 87? Okay, subtract from 180. So if that's 87, which is the shortest side then? KM is the shortest one because it's what? Across from angle L. So KM is the shortest side. What's the middle side? LM is the middle side. And then what's the biggest side?
KL.
The biggest side is KL. Or LK. Yep, either one of those is fine.
So that's only whenever it's inside the triangle, when you put both two angles? Because you know how only the first one you put one angle, but down here you're doing two.
These are not angles.
I mean,
These are segments.
this.
Yep. So if they're segments, you have to use 2 letters. Angles, you only have to use 1 as long as it's just that angle. If you had something like this, if you had an angle or a setup like this, could you call this one angle C? Why not? Because there's another angle right here that also has C as a vertex. So what would you call the bottom one? D, C, E. And the top one? A, C, B. All right? Remember, the middle letter should always be what? The middle, the what? Starts with a V?
Vertex.
Vertex. When you name an angle, the middle letter should always be your vertex. You can name these just with 1 letter because they're not shared. All right? So this angle H, angle G, and angle J is fine because they're not shared. Okay, at your boards, do these 8. All right, so how do you do this? I think for the angle part tends to be a little bit more intuitive for people, but this is how I do it when what do you mean? Like, it comes more naturally. The angle part, like the first 4 seem to be a little bit easier, and then when you start doing the sides, it gets a little bit more complicated. What?
The bottom one takes too much time.
Why? Because you have to actually find the other angle. So it does take a little bit longer. Here's my hint for what I do when I'm trying to figure out the order. So for number 3, for example, so looking at number 3, when I'm looking at this, first thing I do is pick the shortest side. So what's the shortest side? AD. Whatever the letter is that you did not use, that's the angle that's opposite it. Does that make sense? So if it's AD, then the opposite angle would be C, because that's the letter you did not use. The second one is DC, so the opposite is A, because that's the angle that you did not use, or the letter that you did not use. And then last but not least, AC, it's going to be D, because that's the letter that you did not use. Same thing goes for sides, okay? So in this one, you figure out that this angle is 70 degrees. If it is 70, which one's your smallest one? 35, which is angle what? R. This is R. So then TA is going to be your shortest side because it's the 2 letters that are not R. Okay? So for example, in number 10, if this one is 90 and this is 56, what's angle L? 44. So what is your smallest angle? This L is your smallest angle, so the shortest side would be BO because it's the one that wasn't included in those 3 letters. All right? Your next one is O, so then that would be LB or BL, whichever one you put. All right, and then last but not least, B is your biggest angle, so the other 2 letters are LO. All right, so does that make more sense? So it's like whatever angle you use, the other 2 letters are the opposite ones. Okay? All right, so that's just putting them in order. But we want to talk, or what we're going to talk about today then, is how we can determine if triangles are even possible to make. So let me just draw something, for example. If I have a line that's, let's say this is maybe about 12 inches long. All right, so this is about 12 inches. And let's say then I draw one that is 3 inches long. All right, so if I draw one that's 3 inches long, okay. If I want to make this a triangle, how would I do it? Add one more line where? I just need to connect those 2 dots, right? Well, let me put a dot. I need to connect these 2 dots. Okay, would it be possible to do that with a line that's only 4 inches long? No, there's only certain numbers that this one could be, because if if this one's 12 and this one's 3, this one probably has to be what? Probably has to be somewhere in that range, like let's say maybe it's like 14 or something like that. Okay? It's not possible to make a triangle with any 3 values. It has to fit into a certain range. So that's what we're going to talk about today, how to figure out what that range of values is. So, for example, when you're looking at a triangle, the theorem called the triangle inequality theorem says the sum of any 2 side lengths of a triangle has to be bigger than whatever the third number is. So for example, in this triangle ABC, if I add together AB and BC, the sum of those, so again, just adding them together, has to be more than AC. If it's not, then it's not actually possible to draw that triangle. All right? There wouldn't be enough distance to go from one point to the other. So looking at number 1, to figure out then if you could make a triangle with these sides, how would you do it? So you got to figure out if all sort of permutations are greater if you plug them in here. So you would say, what's 3 plus 5?
8.
All right, is that bigger than 7?
Yeah.
Okay, so far that works. What else can you add together here? 5 plus 7, is that, which is 12. Is that bigger than 3? Yes. And what's the other one?
3 plus 7.
3 plus 7, which is 10. Is that bigger than 5? Yes. So basically, you've got to go through all 3, and if all of those are true, then could this be a triangle? Yes. All right, what would my inequalities be here in my number 2?
4 plus 6.5.
4 plus 6.5 has to be greater than
10.5.
11, right? What is 4 plus 6.5, Tiara?
10.5.
Is 10.5 greater than 11? No. So could this be a triangle? No. So it's not possible that that's a triangle. It has to be more than. So it cannot be worth the exact amount. It has to be more than. That's a good question.
It's not greater than or equal to.
Yeah, but it's not equal to. Yeah. So what Gabriel is saying is, does it work like greater than or equal to? No, it doesn't. It has to be bigger than. All right. What would you do here? Plug it in. What are you plugging in?
3.
3 for n. So what's n plus 5? 8. What's n squared?
9.
And what's 2n? 6. Okay, now, is this a triangle?
Well, we don't know. We got to do 8. We got to do
Okay.
9 plus 9.
8 plus 9, is that bigger than 6?
Yeah.
Yes. Is 9 plus 6
Yes.
bigger than 8?
Yes.
And then is 6 plus 8 bigger than 9? Yes? So yes, yes, and yes, this is a triangle. What? It has to be bigger than the third side. So the sum of the 2 has to be bigger than the other one.
So that's the only way you can find out if the sides are different.
If that would make a triangle or not. Yep. And again, the reason for that is, so for this one, for example, if you had a line that is 4 long and a line that is 6.5 long and then a line that's 11, that line would be what? That line's too long. That doesn't make a triangle because it's too long. Okay? All right. So if the length of 2 sides of a triangle are 6 and 11, find the range of possible lengths for the third side. So let's say, for example, that one side of a triangle is 6 and one side of a triangle is 11. And I want to know what all the possibilities are for this triangle. How could you do that? How could you do that?
Oh,
Tiara, what do you think?
could you access 11 and that'll get you
17?
fix it whatever is greater than 7.
Okay, so let's say, for example, all right, let's say it were 6 plus 11 equals 17, right? So that means if it's 6 and 11, could the other side be 17? No, but it could be anything what? Lower than 17. So it could be anything less than 17. Because if it's 6 plus 11, then the other side could be, and that equals 17, then the other side could be 16, 15, 14, 13, 12, 11, 10, right? Could it go all the way down though? No, why not?
Because it's going to be less. It's going to be,
There's some limit on the bottom, right? How do you find the lower limit? Subtract them. What do you get? 11 minus 6 is 5, so that's your lower limit. So that means that this side here Let's call this x. All right? X has to be less than what? 17, but bigger than 5. Okay? Because if you pick any number in there, so give me the numbers that are in there. Could be 6, 7, 8, 9, all the way up to 17, right? So all the way up to 17. If it were 4, let's say you tried 4. 4, 6, and 11. What happens when you add together 4 and 6? It's 10. Is that bigger than 11? No. And therefore it's not a triangle. So when you're looking for the range of values, how do you get the bigger number? Add them. How do you get the smaller number? Subtract them. And then x is just your unknown, and it's in between. So it's always with these less than signs like this. It will always look like those less than signs. So let's say, for example, I had a triangle with legs. Leg 1 is 12, and leg 2 is 7. What's the range of values for leg 3?
18, 19. The greatest, 19.
So x is in the middle. What's the limit on the left side? 5 is less than x, which is less than 19. Good. Okay? Has to be between 5 and 19. What? What's 12 minus 7? 5. So that's where you get your lower limit, from subtracting them, and your upper limit comes from adding them. Siggy?
Could it ever be like the same number?
What do you mean?
Like, you know how this one is 5 and 19, right?
Yeah.
Could the leg be 5 or 19?
No, it couldn't be exactly 5 or 19 because it has to be actually bigger than that. Good question, though. So again, that's why we don't put the less than or equal to sign, because it can't be equal to 5. It has to be bigger than 5. It could be 5.1. Could be 5.000001, but it has to be something bigger than 5. Okay? All right, go do these 8.